we are going to start a new topic. We're starting topic 9. We're going to start with lesson 9.1, which is on equivalent fractions, which is found on page 222, 223 in your textbook. Okay, so let's get our books open and spirals ready to go. Get your heading on your spiral, and we're going to start today. Here is our objective. Our objective today is I can replace a given fraction with an equivalent fraction. So let's get that in our notes. And then right away after you get your objective, you could go ahead and write our question. Well, how can you find equivalent fractions? Okay, and that's the question we are going to answer. And we're going to be able to replace each fraction with the equivalent one by the end of the lesson. Okay, you can also get down the definition of equivalent fractions. And that is fractions that have different numerators. Again, numerators being the top number of your fraction, and denominators. Denominators are the bottom number of your fraction, but name the same amount. And here I put the example, 2/3 equals 4/6, which is equal to 6/9, which is equal to 8/12. All these fractions name the same amount. And I put on here, look at the picture. And that's where we can start now in our textbook. At the top of page 222, they rephrase the question, how can you find equivalent fractions? The same thing I have on the board. It gives the definition again, and then there is the picture. You will see there at the top, you will see that 2/3 is represented by the orange pieces. You will see that 4/6 is represented by the green pieces. You will see that 6/9 is represented by the blue pieces, and 8/12 is represented by the black pieces. You will see, even though they are different colors and different numerators and denominators, actually just denominators this time, you will see that they all, though, name the same amount. They all take up the same amount of space. Now, to maybe help you clarify or get a better understanding, before we hop into all the fractions, let's take it to something we're more comfortable with, which you all know you're comfortable with money. So we can kind of make this and make a connection with money. It says you can also think about money. I put up here. This is not in your book, okay? It says how many ways can you show $1? How many ways can you show $1? By using different kind of coins. So we can use what? We could use oh mercy. We can use 4 quarters. Write that down while I play with the smart board. You can use...
disconnected.
There we go. Okay, so we can have 4 quarters. We could have how many dimes? We could have 10 dimes. Okay, so even though I have a quarter is a different amount of money and 10 dime is a different amount, it still will equal up to $1. So just to kind of help us get a little thought going through, even though it's different, it's still the same amount. Different type of money, it's still the same amount. Okay, good. Hopefully that'll get your thoughts thinking, and we can go on now and find out, well, how can I make equivalent fractions? Okay, this is at the top of page 223. And one way they have here is that you can multiply both the numerator, our top number, and the denominator, our bottom number, by the same non-zero number. So we're not going to multiply by 0, okay? So if you look in your textbook there at the top, it says 10/15, and you will see they multiplied the top and bottom by 2. So let's get that example down. So they have 10/15, okay, and they decided to multiply the top and bottom both by 2. Okay, again, it says you can multiply, but you have to buy the same number. These two numbers can't be different. So 10 times 2 gives us 20, and 15 times 2 gives us 30. So 10/15 is equal to 20/30. Those are equivalent fractions. This names the same amount. We could also take 10/15 and multiply the top and bottom by 3. If we multiply the top and bottom by 3, 10 times 3 gives us what? 30, and 15 times 3 gives us 45. So 10/15 is also equal to 30/45. Okay, so whenever you have a fraction and you need to get an equivalent fraction, that's what they're going to be asking us later, is to give us 2 equivalent fractions for one given. You can multiply by 2 and by 3. Or you can multiply by any number as long as it's not 0 and 1. Because obviously if we multiply by 1, you're going to get the same what? 10/15. So that wouldn't be another fraction based on our identity property. So if you are asked to give two equivalent fractions, you can keep it basic and multiply each by 2. And then you see I rewrote the same fraction and multiply that by 3. So now I have two different equivalent fractions, 20/30ths and 30/45ths. Okay, good. Now you will see in the book that that's all the examples they give you. So I am going to give you a couple more, so make sure you are writing these down. These are not in your textbook. Let's do 1/12. Let's do another example. Let's have our fraction as 1/12. They would like us to give two more equivalent fractions. I'm going to stick with multiplying by 2 and 3 because those are numbers we are used to using. So what is 1 times 2? 2. What's 12 times 2? 24. Good. So 1/12 is equal to 2 24ths. Names the same amount. All right, they want us to give another one. So I'm going to take my same fraction here. I need to recopy the same number that we started with and multiply top and bottom, numerator and denominator, by 3 to get another equivalent fraction. What's 1 times 3? 3. Good. What's 12 times 3? 36. Good job. So another equivalent fraction for 1/12 is 3/36. All right, good job. Let's try another one. Let's do 3/6. Again, to get equivalent, we can multiply both top and bottom by the same non-zero digit. We're going to start again with 2's. What's 3 times 2? 6. Good. What's 6 times 2? 12. Perfect. So 3/6 is equal to 6/12. All right, let's take our first fraction again, 3/6. Let's get another equivalent. This time we're going to multiply by 3. 3 times 3 gives us what? 9. Good job. And 6 times 3 gives us 18. Perfect. So another equivalent fraction for 3/6 is 9/18. So two equivalent fractions for 3/6 is 6/12 and 9/18.